So in this video, I'll talk about the mathematical models associated with vectors. So as I said before, we're dealing with right triangle trigonometry. So here I have a triangle. This is a right angle here. So the hypotenuse we'll call vector A. Now, in the x direction, we have a vector A sub x. So that's the x component of vector A. So this is the x hat part of A. Similarly, this y, that's the vertical or the y part of A. So A is made up of an AX part in the x direction plus an AY part in the y direction. So the way vector addition works, that tip to tail, so the tails start here. So if I start here, go AX to this point, plus AY starting at the end of AX to there, that gives me A. So mathematically, A, this thing, equals AX plus AY. That's what this equation says. Here we have an A. It's the same A, but there's no vector symbol over the top of it. What that means is this is a scalar. Without the vector symbol on top, that means it is the magnitude of A. So this is the A vector, and this is the magnitude of the A vector. So the magnitude of the A vector is the square root of the magnitude of AX squared plus the magnitude of AY squared. And that should look familiar because that is Pythagorean theorem. C squared equals A squared plus B squared, where this is C, this is A, and this is B. So AX squared plus AY squared equals A squared. And then if you square root both sides, you get that. AX, so this one here, no vector, so the magnitude of AX is the magnitude of A times the cosine of the angle theta. So the angle theta is here, so that's the magnitude. So the magnitude of this side is the magnitude of the hypotenuse times the cosine of that angle. The magnitude of the opposite side is the magnitude of the hypotenuse times the sine of that angle. That's what this is. These are the SOHCAHTOA. This one is SOHCAHTOA. So if I take tangent of both sides here, then you have the tangent equals opposite over hypotenuse. So this is SOHCAHTOA, written in slightly different form. So this is Pythagorean theorem, this is SOHCAHTOA. We'll also deal with relative motion. Relative motion, V13, these V's are velocities. Okay? It's definitely clear this time that they're velocities because they've got the vectors over top. So they're not speed. So that's the velocity. In this case, the velocity of thing 1 as seen by thing 3. So this is the velocity of thing 1 as seen by thing 3. So imagine you're sitting in a car. You're driving along, thing 3 we'll call the Earth, and thing 1 we'll call you. So this is the velocity of you as seen by the Earth. That's whatever speed the car is going. If thing 3 wasn't the Earth, if it was a person sitting next to you in the car, then the velocity of you, compared as seen by the person sitting next to you in the car, they would say you're not moving. So that's what this relative motion is about. So we'll go through this. This is how the relative motions of 3 different objects, thing 1, thing 2, and thing 3, are related. Also, 2 things are related to each other. If we walk past each other, I would say, if I'm going this way, I would say you are going, say, east relative to me. If you were walking this way, you would say, no, what's happening is I'm going west compared to you. So that's what this opposite sign here is saying. That if you compare, if one thing looks at the other, it will say that it's moving the opposite direction and actually at the same speed as itself.